Astronomers have long puzzled over the snowman-like shapes of icy objects in the outer solar system. We're diving into the surprisingly simple physics that might be responsible. Far beyond the familiar planets and the chaotic asteroid belt lies a region holding untouched building blocks from the solar system's dawn. These objects in the outer solar system often exhibit a distinct snowman shape, consisting of two connected spheres. How did they form without violent collisions? Past Neptune is the Kuiper Belt, home to icy, primordial objects known as planetesimals. These are the building blocks from the earliest days of our solar system. About 1 in 10 of these planetesimals are contact binaries, objects shaped like two gently connected spheres, much like a cosmic snowman. The prevalence of these contact binaries, about 10% of all planetesimals, suggests the formation process cannot be rare or rely on exotic special events. Scientists got their first close-up images of these formations thanks to NASA's New Horizons spacecraft in January 2019, prompting renewed investigation into their origins. Michigan State University researchers have developed a simple theory. These shapes are formed naturally through gravitational collapse. Graduate student Jackson Barnes created the first simulation that naturally reproduces the two-lobed shape of contact binaries through gravitational collapse. Earlier computational models treated colliding objects as fluid blobs, which merged into simple spheres, making it impossible to form these unique snowman-like shapes. Barnes's new simulation provides a more realistic environment, allowing objects to maintain their strength and simply rest against one another after contact. Thanks to MSU's Institute for Cyber-Enabled Research, the high-performance computing cluster made this complex and more realistic simulation possible. Unlike previous fluid blob models, this approach includes the physics needed for objects to retain their structural integrity, which is crucial for the two-lobed shape. Planetesimals are the first large objects to form in the solar system, created by pebble-sized materials aggregating together under gravity from a cloud of tiny materials. Think of it like individual snowflakes packing into a snowball. These primordial planetesimals are built up from these smaller, pebble-sized objects. Occasionally, as the rotating cloud of material falls inward on itself, the object can be ripped apart, forming two separate planetesimals that then orbit one another. In the new simulation, the orbits of these binary objects spiral inward until they gently make contact and fuse together, all while maintaining their round shapes. This orbital decay is the key mechanism that brings the two planetesimals together gently, resulting in the contact binary shape we observe. The reason these two lobes remain fused throughout the history of the solar system is simple. Without a collision, which is rare in the sparsely populated Kuiper Belt, there's nothing to break them apart. Barnes's model is the first to legitimately test and reproduce contact binaries through gravitational collapse. The team will continue working on new simulations to explore binary systems of 3 or more objects.